So our third session, we're calling The Future is Now Warming Up to Hot Water. This is tackling the seemingly intractable problem with electrifying hot water systems. So this panel will be moderated by Nicole, Ceci from Stephen Winter Associates. And Nicole's seen more heat pump water heating systems than anyone that I've met, certainly. And this is an interesting group of panelists because all the firms that these folks work at have worked with the other firms on various projects. So we're going to present to you 5 very, very short case studies for specific multifamily buildings, all of which have won awards in NYSERDA's Buildings of Excellence competition. So first we're going to have Sara Beyer from Magnusson Architecture and Planning, and she'll present 4 of them, and then Grayson Jordan from Paul Castrucci Architects will follow up with the 5th case study. Then Ryan Cassidy from RiseBoro Community Partnership, and then they'll be joined by Avery Gray from Bright Power for what's I'm sure to be a very interesting conversation. So actually, Sara, if you'll come up, and the rest of you, actually, if you want to take a seat there, it's more comfortable to watch from the audience. And then if you'll pass it to Grayson. And if you want to take a seat in the audience, you can do that.
Okay. All right. Hi, everybody. It's wonderful to be here. MAP is a purpose-driven firm, meaning we support the mission of our clients to provide healthy, safe, and affordable housing. For over 30 years, we've been a part of the active growth in healthy and energy-efficient architecture, which I think we should all celebrate, which is central to supporting our clients' missions. We are seeing a widespread implementation of electric heat pump technology for hot water. Of these 7 Buildings of Excellence projects, all are electric except for one from round 1 of the program. In fact, another project from round 1 that still had gas when it was awarded has now switched to all-electric heat pump during construction, partly to avoid gas infrastructure upgrade requests by National Grid and to align their building with our swiftly emerging carbon-neutral future. In 2021, our firm alone had 13 projects that were all electric in design and only 2 projects that still had gas domestic hot water. Here are 3 of those all-electric buildings currently in construction. This project, Linden 2, is part of a 3-phase development encompassing a full city block in Linwood, Brooklyn. The first phase is completed and was not part of the Buildings of Excellence competition. However, the second phase was a winner in the first round. It's an 8-story, 160-unit, 100% affordable multifamily project, and it's fully electric and nearly completed. Linden 3 is a 3rd phase in this development and was a 2nd round winner. It's also 8 stories, 100% affordable multifamily housing, and it's fully electric and foundations are almost complete. As you probably all are aware, accommodating the peak hot water demand load for multifamily buildings is different with a heat pump. There are typically 2 peaks, one in the AM, one in the evening. Most gas systems work in real time to accommodate those peak loads. Heat pumps are far more efficient, but they work more slowly over time and cannot respond as instantaneously to those demands. So these systems require a substantial volume of hot water storage capacity, enough to accommodate that entire peak load. The gray line here represents the amount of hot water in those storage tanks. Over the course of the entire day, the heat pumps work to recharge the tank. The tank then becomes sort of a hot water battery. The energy use can be spread out over the course of the day and night, which reduces peak demands that might cause dirtier peaker plants to come online. Or in the case of our near future renewable grid, this hot water battery strategy can actually help shift energy demand to when there is more plentiful renewable energy available. So with a heat pump hot water system, we are also becoming better grid citizens and can contribute to demand response strategies. These 2 buildings each have different ways of supporting the domestic hot water system. One has a solar thermal array that directly heats the water for the storage tanks, and the other has a PV array that provides renewable power to the heat pumps. We are looking forward to comparing the performance of these 2 systems of the buildings right next to each other. Another all-electric project is DeKalb Commons. It's an affordable housing development for families, providing studios through 3-bedroom apartments. It's located in Brooklyn and comprised of 2 7-story buildings across the street from each other. The owner is St. Nick's Alliance in partnership with Bed-Stuy Restoration. Our energy target is 2015 FIAS certification and starts construction next year. Here's a summary, probably a little small, but you're probably all aware of these strategies. Here's a summary of the efficient and health measures for this project and for projects like it. Represented in red on the right is the domestic hot water system with the heat pump condensers on the roof and storage tanks in the cellar. This being a block and plank building, it made more sense structurally to place the tanks in the cellar. We insulated the hot water piping between the two above code minimum to keep things efficient and reduce internal heat gain in the building. When the decision was made to move to a heat pump system, the team conducted a cost comparison. A heat pump capital cost is about 3 times more, not including savings from removing gas infrastructure from the building though. But operating costs are about 15 to 25% more because heat pumps are far more efficient, and gas at that time was even cheaper. At the time of the study, this meant about $1,000 more a year in operating costs. This diagram is about air source heat pumps for heating and cooling, but I included it here as a reminder of how critical it is to use lower global warming potential refrigerants where we can, and how careful we need to be to make sure these closed loops remain closed. In a split VRF system, there is always the assumption that there's a small amount of leakage, although we don't have great data on that. Therefore, reducing the lengths of your refrigerant lines not only save upfront costs, but it will also reduce the risk that our electrification systems won't backfire from a global warming perspective. We are looking always to specify a CO2 refrigerant in our domestic hot water systems. This is the Rise, which is located in Brownsville, Brooklyn, and being developed by Zenalift Partners. It's a 7-story building with 72 dwelling units, both affordable and supportive, and the 1,300 square feet community facility office space at the ground floor and cellar. The building is CMU block and plank with precast plank and a brick facade, and we'll just start construction this fall. It's also all electric and the passive house features in it as well are critical to providing the health and wellness strategy for this project. It seeks to support justice-involved families who will live here. There are multiple services and amenities, including 4 outdoor terraces and urban farming, and the no fossil fuel combustion on site will ensure we're truly providing healthy homes. Passing it to Paul.
Hi, everybody. Happy to be here. I will be mercifully brief. I have one project to present today. I'm Grayson Jordan. I'm a principal architect at Paul Castrucci Architects. We're architects who care a lot about sustainability. Most of our work is passive house, something like it, and we tried to do work in affordable housing mostly, but we do multifamily and other typologies. So today we're talking about Bethany Senior Terraces, which is a project we're really proud of, working with another presenter here, Ryan in RiseBoro Community Partnerships. It's a modular passive house, fully electric, affordable housing for seniors building, slated to start construction at the end of the year. It's in Brooklyn. This is a slide that when we're talking about climate and passive house, that we often show. And this just touches on something that a couple of panelists that went before us have talked about, which is that when we're this specifically looking at trying to get to local law 97 requirements, how do you get there? We think that the smartest, easiest way, and I think probably most people in this room agree, is to be really energy efficient. So to use passive house not as a certification tool, but really as a design tool to drive down energy costs as much as you can, and then get under those thresholds and avoid fines. And then added on that, when we're talking about electrification, electricity is expensive. And so as we're electrifying our buildings, which we think we need to do, we want to make sure that they're really efficient, so we're driving down the cost of sort of operating those buildings. So here we are, Bethany Senior at Flatbush area of Brooklyn. So the building is about 40,000 square feet, 58 units. The energy metrics, it is going to be Passive House certified, and it's using about half as much of the allowed carbon for the 2035 plus allowance from the calculators online. As I said before, it is a modular building, so we're looking to lean into that and sort of begin to carve away some modules on the south side of the building to create sort of a continuous walking loop, an activity loop, and also indoor-outdoor terraces. Because, we care a lot about sustainability, and of course that's energy, but a biggest part about sustainability is that people want to be in the buildings, that they're happy there, that they're comfortable there, that they love living there, and that it's a building that they want to preserve and sustain. So here we're looking at the feature of the building, so the south side, all these indoor-outdoor spaces, and creating really just a place that people want to be. As I said, again, a modular building. Here we're just not as relevant for this group perhaps, but just looking at the scope delineation of what's modular and what's not. But that thinking in modular terms really did play into sort of our approach to MAP, which is the electrification, and specifically looking at the sort of VRF system. So typically you would have sort of a centralized system, ERV system, which is the energy recovery ventilation system. Typically, we would centralize that. That's what we typically do in building, but here it made more sense to do it. Each module gets its own, and then we just have to think about, where's the exhaust going out, where's the supply coming in, making sure those are properly located. And the other sort of complication with that is that you are placing the units inside, so you have to be able to get in to maintain them. I think in this case, it's seen as an opportunity to sort of check in on sort of elderly residents, but that would be another consideration of that approach. Okay, hot water. So this is our first, we have done electric hot water on small buildings before, so 1-2 family buildings, it's quite easy. You do a heat pump hot water heater, you throw it in, it's very easy, it's known, people have done that all over the place. This is our first chance at going electrified hot water at a sort of a medium or larger scale. And so our approach here, we've actually gone through 3 different iterations. And the first was, I have to sort of check my notes here, I don't want to say the manufacturers, but the first was essentially heat pump, air source heat pump on the roof. We used a hydronic non-potable loop to run between that into an interior hot water tank, sort of that battery that Sara had referencnced. And then we looked at, and Ryan may talk about a little bit more about this idea of using heat recovery off that. So we have VRFs to heat and cool the building. How can we use some of that waste energy to heat and cool, to heat the hot water? And so we looked at that. That ended up being too costly for the project. And so our final, where we ended up, was with a CO2-based sort of modular unit. They're pretty small, they're 15 MBH each, and you sort of, you add as many of them together as you need to get up to the load. Ours ended up being 9 of those units. They're located at the roof. With this particular unit, you get rid of that non-potable hydronic loop between the systems, but essentially the water passes right over the coil, but that means that the heat pump needs to be very close to the hot water tank. So just before I wrap, this is a typical passive house detail. And again, I just want to underline the point on electrification is that as we're electrifying, sort of the way I see it is that the real work in making affordable electrical buildings is really driving down the cost to operate the buildings. Electric is more expensive, and so we need to make really efficient buildings, drive down that cost, and then also look at how can we begin to get policy to change around things like solar storage, leverage demand response, time of use, and things like that to really capture all the savings on the cost side of these electrified buildings. So with that, I think I thank you for your time. I think I'm going to turn it over to Ryan.
Hi, I'm Ryan Cassidy from RiseBoro Community Partnership. It occurs to me as I listen today to all the really smart architects and engineers that my job's a little bit different from those folks. It's really to keep responsibility with contractors and our development team to deliver these types of projects. And so we don't value engineer any of our passive house things. We don't value engineer, hot water systems when we develop them. And it's really about keeping pressure on contractors to deliver what we want. And so that's sort of my role at RiseBoro. So this is Bushwick Alliance. It's a 20-unit multifamily affordable housing project developed with RiseBoro and St. Nick's Alliance and designed by Stat Architecture. It was the winner of NYSERDA's Buildings of Excellence Round 1. It's passive house compliant, low carbon, and fully electric. The big thing here on low carbon was just getting a concrete mix that had less embodied carbon, and that ended up being pretty easy to do. So we were able to deliver that at no added cost, and all it took was a bunch of conference calls and complaining from contractors and things like that. But it was zero cost, and we said we were going to do it, and we just pursued it through the end. So that was good. Hard cost, it's a little more expensive than we would like, but it's a small building, so that's kind of reflected here. We generally try to land these passive house projects between like $350 and $375 per square foot. And then the main thing also in our development is how we underwrite these projects. So RiseBoro's been building new construction passive house now for 10 years, and so we've got quite a bit of data on how those buildings perform in the real world, and the good news is that they do perform. So we get a lot of banks that come to us ready to underwrite to models or a percentage of the model, which is really helpful. So in this typical case, it's a small building, but our underwriting would normally be like $44,000 a year, and we're able to underwrite to savings at $33,000. So it's a good amount of savings that even $11,000 can be leveraged into a nicer debt sizing or less subsidy, depending on the approach. So that's great. And then we are expecting to get into construction in June. That's today. We're going to close probably later this month. And so here's our hot water strategy. So we've done a lot of passive house. So for us, this wasn't a question of whether or not we could do passive house or anything else. It was really how do we incorporate electric hot water. And of course, with PCA and the project Grayson just presented, we've got now two of those in our pipeline. So it's a similar system. It's a Colmac water heat pump, and we've got 2 storage tanks at 400 gallons for the 20 units. It's located on the roof in a mechanical room, so nothing really unique there. And then this is sort of our condenser layout along with our hot water heaters. So it's something that we haven't managed. So RiseBoro also manages the properties we own. So we have about 2,000 units under management. And so this is kind of our first foray into what this might look like. And so we didn't take a lot of benefits if I were to go back to the underwriting. Most of the underwriting benefits we took were just on the energy performance. So we wanted to stay really conservative on our hot water assumptions, both for efficiency and for the Con Ed rates, which are going up. So as we approach these projects for the first time, we like to stay conservative on things that are new to us, and then we continue to pursue passive house cost savings that we're familiar with. So that's why we can land at those numbers. So we're excited about the project to get in the ground along with the PCA modular project, and look forward to talking a little bit more.
Okay. thank you all for presenting those projects and for setting the stage. Everybody that is on the stage right now has worked on different projects that were presented there in different capacities, and so there's a lot of crossover between the professionals that are on the stage right now. I'm going to start off with asking some questions. I get to jump to the front of the question line because I'm sitting here. But please, everyone, keep adding questions into Slido. I will just remind everyone that these projects have a lot going on. They have really exciting systems for basically every system, and the architectural components, everything about them is exciting, cutting edge, and amazing. But we're talking about domestic hot water. So my personal favorite topic. So please try to keep questions mostly focused in the DHW area. Similarly, answers, try to keep bringing them back to DHW. With that, I want to start off by asking a little bit. There was something that actually, Ryan, you mentioned in just kind of as an aside comment in your presentation about how you've done passive house before, but domestic hot water, electrifying domestic hot water is new. And that's something that I've seen a lot of. Our firm has worked on lots of exciting, big, cutting-edge passive houses, and they've all had gas hot water. So it seems like domestic hot water has been sort of the last frontier for electrification. But here we are with 4 people on a stage talking about a whole bunch of projects with electric DHW. So what is it that has made everyone make this switch now? Why now?
That's a good question. I think the reason that we didn't approach it earlier was because, if you're in a passive house environment, you can certainly understand load reduction and what passive house load reduction does to a budget. It's harder to understand that for hot water, and the load reduction pathways on usage are a little less clear. So I think that's what, especially for companies like ours that manage buildings, that's what kind of held us back from those maybe earlier rounds. The reason now, the 2 biggest reasons are probably current code enforcement, and the way the stretch codes are going to be hitting over the next few years, that it's clear that this is where it needs to go. And then the second one, at least in Brooklyn, was when there was that national grid. I think they thought they were leveraging their power, but what they really did was created an environment where suddenly developers that were in construction were hearing they weren't going to get gas, and everyone just started designing to all electric. So that was kind of an unintended consequence of that negotiation a few years ago, and that was one of the things that pushed us as well.
I think also, can you hear me? I think also it reflects how quickly the technology is changing and the availability of products, and also the long lead time of construction projects. So there were very few, and still are, limited number of the air source heat pumps and hot water heat pumps available, but that's changing very quickly. There are a lot more coming online, and they're still pretty expensive, but they're going down in price. And I think these projects are kind of the leading edge of that, but a project takes a long time. So in our pipeline, we're seeing a lot more come on that are still in the design phase. There aren't too many really going into construction yet, but I think it's really going to pick up quickly.
One last thought is nobody wants to be first, and so having development partners go help lead you along, and also other architects who are sort of blazing the path. That's what sort of has led us into it.
Great. And with that, maybe I'll ask an architecture-related question. I'm curious if any of the architects on the stage can speak a little bit to some of the architectural considerations that come with domestic hot water. Thinking about things like coordinating roof area or landmarks issues that come up, anything like that. What is that, the getting out of the MEP side only of DHW, what are some of the architectural considerations that do come up?
About space on the roof. It does take up a little bit more room, but if you don't have a gas room in the cellar, that's probably a good trade-off. But there are zoning restrictions now that limit the amount of mechanicals above your maximum height on that roof. Hint, hint. But it hasn't posed a big issue for us right now because a lot of our space conditioning, we have combined condensers on the roof. It might pose a problem for a market rate building. Yeah, so you don't have that gas infrastructure down there, and you know, placing the tanks are pretty large and weigh a good bit, so you want to place those in a structurally feasible area. And if it has to be separated from the condensers, definitely insulate extra between the two so you don't lose efficiency and have internal gains. And you know, keeping the load demand down, which we have a lot of great work already done for efficient fixtures that work really well now. And you know, actually the sizing of it, I hear, is a little bit little bit difficult. Sizing domestic hot water, you know, you've always been relying on a gas that can just pop on really quickly and take an extra peak load. And I hear from the engineers, they're not uncomfortable about it, but they wish there was a little bit more data on the usage of hot water in multifamily buildings.
A couple of things to add to that is the, as Sarah said, the putting the more stuff on the roof, which then can take, it's not a lot more stuff, but it is a little bit more stuff, which takes a little bit away from an area you could put really cheap solar, so ballasted solar. But again, it's not that much area. The system we use is sort of a system that can be scaled up to different sizes. We have a fairly, not a huge building, but as you got bigger, those number of units could potentially begin to take away a significant amount of solar, and you'd probably also, if you got tall enough, begin to have to zone it. So you'd have some, you know, we showed you a 4-story building, but you know, at 15-story building, you're maybe looking at 2 different zones, so you have setbacks at 2 different locations. And then, not specific to that project, but to a retrofit that we were looking at, we had wanted to have the hot water tanks in one location, but because that system needed to be the condensing unit needs to be close to the hot water tanks, it ended up being somewhere else where we could put the condensing units.
Yeah, that brings up a good point. The projects that we're talking about today, the projects that were presented, those are all new construction projects. What lessons have you learned through, you know, designing these projects that you think might also be applicable in the existing building world?
One thing we've done is, you know, steam boilers produce a lot of excess waste heat in the cellar. So on those retrofit projects that want to do this, the heat pump hot water, you put the outdoor units in the cellar to capture all that waste heat, which is often done in single family too, you know, with those combined units with the tank and the condenser right there. And that works really well for probably the remaining useful life of that equipment. And it pairs really well with, we're pairing that kind of retrofit situation really with solar, so that the marginal, you know, operating increase is offset by solar.
Great. And I'm wondering, maybe if we take a half a step back for a second. You know, I think we have a tendency to talk about how exciting and how great everything is, and how, you know, now is the time. I mean, I even opened this with, why are we doing this now? Now is the time. Look at all this great progress. Can we talk a little bit for a minute about maybe what's gone wrong, what challenges you're running into, what hurdles you're running into? Were there dead ends on these projects? I mean, you know, you mentioned a few of them, Grayson, like looking at different systems along the way. What hurdles and what roadblocks are you all seeing?
So for Bethany, actually, so the electrification decision came during the design process, so it wasn't a first instance. So I think that's always a little harder as you're sort of trying to wrap it in. But with the first system that we looked at, and especially with the heat recovery, just the amount of refrigerant line was really intense. And I know Sarah showed a really nice slide about how to manage that on the VRF side. But on the heat recovery side, so where one thing that Ryan has really been pushing, which I think is smart, is using the heat from the the heating system to help heat the hot water. But in our first pass at it, first of all, I think it was new to the manufacturers a little bit, and so we were sort of talking it through for the first time, or one of the first times. And then just really what made us have to pivot away from it was just the sheer amount of refrigerant lines was just too much, and both from an environmental but also really basically from a cost perspective.
Yeah, so asking for things that don't exist is probably a hurdle of mine. But the other thing is really the Con Ed rates. I mean, those exploding just really erode both our ability to underwrite to savings and also, just increase the risk because, hot water risk doesn't go away. I'd feel more comfortable, with passive house performance for heating and cooling that even within higher rates on electric, we can manage that. But it's a little scary to know that someone can just turn the faucet on and whatever's coming out, you're paying at that electrical rate instead of the natural gas rate. So I think that's the biggest ongoing risk. But that's where the policy comes in. And as we decarbonize, it's just a world that we're going to have to live in. So if it takes away the choice of natural gas, then we just have to get used to it. But right now, that's a big hurdle.
Her presentation alluded to a major issue, which is the recharge rate. These systems just run a lot slower than gas, so peak demand is harder, and you solve that by having these big tanks, which have their own issues that aren't insurmountable. They can be solved, but it's something to address. That also kind of ties in with considerations for performing in a cold weather climate like this in the winter and being able to get 140-degree water for safety and for functional reasons. So that seems to be solved by using the right equipment, but we don't have a lot of projects that are built and operating, so that's something we do have to wait and see a little bit.
There's one other issue we see coming up during construction is there is a lot of competition coming, and there are a lot of manufacturers looking at our market and recognizing the opportunity. So our contractors are proposing alternates that don't always quite work. So we have to be very careful about those, and we always welcome cost-saving alternates for the whole entire team. But there are not as many products that are cold climate, have the same cold climate performance that we need.
Off track, but along the lines of something that Ryan said, which is the cost of electricity, and just want to again underline, it's sort of a challenge to us and everybody here is how do we begin to sort of eat into that escalated cost. And I think on the policy side, it's things like getting solar storage back online, and then from our design side, taking advantage of peak use rates to lower the cost a little bit. And then what Avery said also made me think another sort of downside is potentially pushing everything to electric. When the electric grid goes down, you're fully exposed. So again, another place that potentially solar battery storage could help. So
sure, and there are questions coming in, and it's always a big question, thinking about electricity rates, thinking about cost of doing all this. And historically in New York, we have had expensive electricity and cheap gas, and it's always been a struggle to kind of make the argument to switch to the more expensive energy source. And I'm curious how your project teams, and maybe starting with Ryan as the developer on the stage, putting you on the spot a little bit, how we make these arguments and what argument has been successful for going with a system like this that might have a higher net operating equation, a net operating cost, against a gas baseline. How do we win that argument?
Well, I think anytime you're introducing new technology, there is an opportunity to get a real number. I think, a lot of times when we're looking at construction pricing, there's a lot of fat baked in that maybe just accrues over the years. And so there's a number there for, gas infrastructure and for piping of typical systems. And if it's in line with what we've, paid in the past, we may not dig into it. And we tend to operate with lump sum contracts, so we're not doing open book with our GCs. So anytime you get new opportunities and new bidding opportunities, you can really start at like the ground level and get the distributor involved and get the manufacturer involved and like see a real price. And so we don't necessarily see that on all of our deals and all of our trades. So we did it 10 years ago when we switched to EFIS. We went back all the way back to like, what does brick actually cost? And we noticed that over the years that had just scaled up, and that we're paying for a lot of fat. And I think we do that in our infrastructure pricing with natural gas, and we do that with our existing piping for boilers. So it's a good opportunity, I think, to start at ground zero with real pricing and get the contractor in the room early and really develop pricing that's reflective of the real world. And you may find that you actually get some savings against what was quote unquote normal on other projects, because you're rendering out a lot of that fat.
So that would be you're talking about your first costs, your installation costs. But then going forward, if we're talking about heat pumps, if we're talking about electric equipment versus a gas water heater, the cost per BTU, and you mentioned kind of the volatility of electricity pricing as well being a concern. How, as a developer, do you kind of stomach that risk?
Yeah, it's difficult. The one thing is that we never underwrite our energy performance to like whatever, whatever the model is. So we've always got quite a bit of fat in there in our budget. And so, for hot water, it's just something that we have to get comfortable as more of a holistic view of the budget, and not just looking at hot water, because we don't really know much about the performance, and that it's an open question. So I think the numbers I showed are bottom line numbers, and so we know we're going to perform better in heating and cooling, and then we just have to be kind of on target on our hot water so that overall it works out. But Bright Power does a lot of that work for us in translating the energy model into budget models, and that piece is really important. Making sure that the rates are reflective of the new rates. I mean, in the last 6 months, we went from modeling it 24 cents to modeling it 27 cents. So just those types of adjustments over time are really important.
Question of cost also goes to the design and what you can do to make the hot water system more efficient overall and rely less on the creation of hot water, so low flow fixtures, efficient distribution design, etc.
Yeah, it's almost as if implementing this newer technology is asking us to make everything else more efficient, which is a good thing for the whole project, for everything as a whole. So it's almost, when you put your attention on something and you want to make it better, there are ways you find that you missed before.
Right. These buildings are cheaper on the whole, right? We're not talking about more expensive to operate buildings on the whole, and that's sort of the way to couch it, right? Like overall, with the passive house approach and the VRFs, we are cheaper. It's just that this one spot is a little more expensive.
So you're saying I shouldn't just focus on domestic hot water, even though I just want to focus on domestic hot water? That's fair. So there have been a few questions coming in asking about renewables and about supplemental and about geothermal. And I'd like to start maybe passing it to Sara to talk just a little bit about your project. I believe it's the Lindens. You've got one building with electric domestic hot water and solar PV, and another one that's coupled with solar thermal. And maybe if you can tell us a little bit more about those approaches, maybe why they're different, what the thought process was, and then we can open it up to the group in general who's been looking at coupling these with renewables. And one of the questions is specifically, is anybody looking at coupling their domestic systems with geothermal and pulling basically a water source heat pump, ground source heat pump, instead of air source heat pump, which we've been focusing on. But yeah, if we can start maybe hearing a little more about the Lindens and what's going on there.
Yeah, they started their all-electric journeys with the gas moratorium, and originally they were going to do geothermal, but it didn't pencil out economically. But I'm not sure that we were aware of the time of the sort of smarter drilling technologies that are coming to our market. But actually, it was an engineer's what they were very comfortable with and excited about, and they could prove the savings. That has a lot to do with what we're doing on projects, is what people are comfortable with and what they've seen work before. So that's how solar thermal partially, came about there. And then on the second one, I think they might have wanted to see the two operating next to each other and how it would work out. So we're also seeing, like you said, other technologies to capture waste heat that I'll let others, talk about, but there's a lot of tools out there that are coming online, and now is an extremely exciting time to throw that spaghetti on the wall and test them out.
And has anybody looked at renewables in any of these other projects, and specifically geo as a kind of renewable adjacent piece of this conversation?
As Sarah's saying, geothermal historically has been very hard in New York City, so I personally haven't seen projects looking at that. Solar, I think a lot of these projects are using solar. It's not necessarily tied to the discussion of the hot water system, but obviously there's synergies and it's beneficial.
I think I don't have a built example. I guess I'm excited about the design ideas that we're seeing in the form of spaghetti. Capturing heat from your black water and your gray water. We've seen a few studies, we've done a few studies, and there are systems that combine that with making hot water. Obviously only heat is being transferred, but it's there's a lot of waste heat out there. And definitely a lot of people are entering the space to help us solve this problem. So we just got to keep talking.
Yeah, we haven't done geothermal, just the same problem. It's traditionally not enough space from the technology that we're aware of, but this idea of capturing the waste heat from the from the heating systems, cooling systems, it makes all the sense in the world. We just got to figure out how to do it, and we couldn't get there on that last one, but I think it conceptually makes sense, and we'll definitely get there. On the solar part, I think all of our projects have solar. It's hard to make an argument for not putting solar on at this point. So.
Yeah, we have a project that's in construction and has a hot water heat pump system, not shown here, but is using drain waste recovery for the hot water system, and at least from the modeling, looks like it's going to have a really sizable impact. So I think that's something we're going to see more. We've been looking with MAP at some new technologies that are coming on for projects and design. So I think that'll also might be more beneficial than solar, or more tied to these design solutions.
Yeah, our approach on all these, whether it's renewables or more creative ideas like waste heat recapture, is to try to wedge it into a project, but don't underwrite to it. So it takes the risk off of the plate, and it's reward only. If it works, it works. It's great. In fact, on both of these projects, they both have solar, but we don't underwrite the solar piece. So, as the solar savings come in, that's a pretty good belt and suspenders to make sure that we hit our numbers. So, over time, you might want to take more of the solar operating, but if you can leave a portion of that out, and that can just be your buffer from an operational standpoint.
Great, and so that that let us kind of talk about supplementing domestic hot water in the exciting way, which is using renewables, using all of the cool stuff that we want to be using a lot more of, but kind of the pragmatic truth of how a lot of these systems are being built today is that if there is supplementation, which there usually is, it's with gas, which is not the case here, or it's with like an electric resistance backup or something like that. Like, for example, Ryan showed some design details that showed storage tanks with an electric coil in them. And I'm wondering if you can speak a little bit about the conversations of just like what fear is still out there with your clients and project teams around relying on heat pumps versus like needing a backup, wanting a backup, and kind of where is backup being put into these systems either just to like have backup or to make sure that you have hot enough water to prevent Legionella growth?
Yeah, it's very interesting. We have some clients that are very comfortable with what our engineers are specifying. We have just large tanks, and some that are really worried about a large multifamily building needing backup, and so they're looking at geothermal and those kind of other renewables, and we're exploring all of it. I mean. Fortunately, we have very smart engineers out there, and I cannot thank them enough for their leadership, because we know it works, but we do want to, now is the time to really start exploring and studying all of these ideas, because there will be projects that really that might need the supplemental. I can't tell you for sure.
I think we've had similar experience on new construction where there isn't too much concern. Engineers say it's okay and everybody moves forward. I think on retrofit projects that might come in more, and maybe just the psychology of we have the system and it works and we're replacing with this new technology. So we've worked on some of those projects where the gas hookup was capped but left there, and maybe the hot water equipment was left on site just in case. So I think you definitely see that, but it kind of depends on the situation.
And as a developer, is having that backup something that your team felt was needed, or is that really just a safety thing?
Yeah, I mean, I think hot water is kind of like one of those just third rail issues, and you never want to have a building that suddenly doesn't have enough hot water. So we were a little nervous and it's our first building. So yeah, we're nervous on the first time, probably the same way we were on our first passive house, with the idea that, we weren't going to, the building almost had, was modeled almost to not use any heating during the winter, right? And that was hard to wrap our minds around. We know that's true now over the last 10 years. So the idea is that probably all developers are the same way, that you've got to, hopefully these are smaller buildings that we're experimenting with. And if we can see it on the small building, we can wrap our minds around, like, starting to get more aggressive and be more creative on the hot water side. But no one wants to, roll the dice with hot water and have that tenant complaint coming in, in year, 6 months into your occupation, you realize that you're not going to get there. So it's a scary thing.
I'm not so afraid of electric resistance. It's just a small hit on the efficiency right now, I think, so.
Pivoting a little, we've had a couple questions come in that are asking about essentially workforce development. And so as your projects have moved through the design phase, do you have special touch points with the contractors, with the folks who are going to be in the field, maybe with the commissioning teams? Is there any special training that's happening for the installers? Like, what is happening to prepare the folks that are installing what are some of the first of these systems in our area?
It's not directly going to answer your question. I'm sorry. We definitely do on all the projects, not just for hot water, and it's part of the spec book. It's just sort of we're going to have kickoff meetings, trainings with the GC and each of the trades, and that will extend to plumbing, and also in this case to mechanical, because it's a little both. But really on our project, it's less about the hot water and more about the modular nature. It's about who's doing what, where do you leave the connections, and the big part for us on the modular is when are the inspections done, how are we quality control. So not really to answer your question, but directly, but that's where we are on that. So
we are trying to go on tours of built projects, which there are quite a few here, and going with the lead plumber to see it and talking about what they're seeing and what they think about it. It's extremely important to learn and keep the conversation going. So that's one thing. Yeah, and then just quality control in general. I think with Passive House, it's a really good example of how quality control can make a huge difference in a building.
We have a related question that came in that is asking what sort of training is needed to grow the number of these projects that we see. So it's sort of bringing together this question of what training's happening for installers, what lessons are you as design team members learning? How does that all come together to kind of let you see what additional training and education is needed in our market?
Yeah, I think we definitely need more lead plumbers to go out and see more examples and have more programs. Like I think I saw earlier, the Urban Green is developing programs to train installers. And we need that for across the board for all of these technologies, definitely including this one. So every young person I talk to, I recommend that they come into this space because it's growing and it's really exciting, so.
Yeah, I think partially it's just designing and demand for that, those trades. And I think something we've talked about, I think a project with MAP was prefabricated skids was discussed. I don't think it ended up happening, but having the domestic hot water system kind of prefabricated to a certain extent to avoid that lack of the right trained staff on site. So I think there are some ways to work around those issues while the capacity is built up.
Yeah, I would go back to the opportunity of new, and Sarah mentioned this too, of from the design side. Anytime you're doing something new, you kind of reset all those relationships. You know, I would never, on a regular job, go and talk to the plumber about his boiler install, right? Because he's done it for 30 years, and I've seen it happen a bunch of times, and so whatever, it's the boiler. But with you know, with hot water, with these new hot water systems, it's going to be something we talk about, you know, all the way back into the beginning of SDs, and the contractor's going to be way more involved, and I'm going to know who the person is, and we're going to have those conversations. And so it also gives the design team an opportunity to, like, well, why don't we look at this piping detail for the first time in 5 years, and we'll like really re-excavate how we do this. And so it's a good opportunity.
There are also a few questions that are coming in that sort of get at the grid side of things, and I'm not going to put anyone on, end of the spotlight to talk about the state of the power grid, but specifically, are there concerns about resiliency for the domestic hot water system? What happens during an outage? Do these concerns come up in your meetings, and who's saying what about it? Is there an answer? There might not be an answer, and that's okay.
Can I beat the same drum I've been beating? We need to be able to do solar storage in New York. That's a policy change that needs to happen. But yeah, it's a concern. So on the heating side, we know that passive house buildings can withstand power outage for longer than a regular building, but you still need hot water. Some sort of generator is probably the best that we can do at this point. But again, I think there's no reason we shouldn't be backing up our solar with batteries, and we just got to find a way to get the policy aligned with the will.
Both of our projects, you know, the city, they're affordable housing projects, and the city wants to see backup generators. And so we told them, you know, we're starting construction now, and we'll be done in 2 years, and we expect at the end of 2 years that we're going to be in a different policy world, and we've got a solar storage world that we can, you know, live in and provide that hot water, because otherwise we're decarbonizing, but, you know, we're still pulling gas lines in for generators. And so we're kind of skipping over and hoping that the policy catches up. I mean, the technology, I think, is there, but really we just need to get the policy straightened out.
Yeah, one thing we remind people of is that your gas boiler isn't going to work in an outage either. But definitely understand the need for resilience, and actually in senior projects, HBD requires we have a generator or some kind of resiliency. So we continue to study the battery question and size a battery for each project to see if we can do it and what would it carry. And, just even preparing like the what was mentioned before about making incremental steps. You can make a place battery ready, or your building battery ready, provide non-combustible construction, a standpipe to the location, your fire alarm, prepare your fire alarm for that. And you've done, you've added something that will get you there in the future, so. And in terms of the grid, Urban Green has a fantastic study that was mentioned earlier about the capacity of the grid. I definitely am not worried about it, but I do think that our batteries and our water tanks can serve as part of grid resiliency. We can be a part of that bigger picture to support the grid.
Great, thank you. The point about our fuel-fired systems not working during a power outage often gets skipped, and it is a significant one. The fans, the blowers on a traditional boiler, they're big, and they require a lot of power. So we're nearing the end of our time, and I think to wrap up, the question that I'd like to have you all kind of mull over a little bit to leave us with is what's something from these projects that you think you've worked through, learned, discovered, that you're going to take forward with you to your other projects? What's kind of a piece of this that you really want to carry forward and kind of help scale our electrification efforts in New York with? Don't all rush.
I'll go. No, wait, am I ready to go? Well, first of all, I've learned from these guys up here, so really smart commentary, and I'm going to take stuff from these folks. But I think we are going to, I would say, like RiseBoro brought us along to the hot water question, and now we're gonna bring that along to the next folks, and I think hopefully by the time those next designs are coming into play, some of these case studies are going to be online. And we're going to be able to point, because we really, you asked a question earlier, I didn't jump in on the resistance we get. I think partially is from what Ryan was saying, is that we don't want to lose our hot water, but really that I don't want to be the guinea pig to try this. And so that is my hope, that these case studies are coming online and we're getting these hot water systems really as the baseline, just like passive house or really energy efficient buildings is the baseline and is almost becoming code. That in the next couple of years that we're going to see fully electrified buildings just as business as usual.
Yeah, so that's our takeaway, is that, the design side we've just gotten comfortable with. That at least, 2 years ago we weren't sure about the feasibility of all electric, and now we know that from a design side it can work. So it's our new basis of design, and we'll take that and just pursue some of these more creative solutions as we move along to like the next generation.
Yeah, I think just a topic a point that's been brought up a lot is just interrogating the kind of basis of design and status quo, and just kind of asking the question and seeing if you can improve it, looking at these newer technologies and newer products that are coming on and exploring those as well, the same way that these projects were new when they were designed.
Yeah, along the same lines, we all like to have productive, efficient meetings, an agenda, and we all say what we need to say. But some of these meetings, especially in the early phase, are going to need messy, very loud, or very quiet, uncomfortable meetings where we're like, does this really work? Who knows what? Where can we get the information? It's gonna, but it's so worth it, because obviously we are on the same boat, and it's just been incredible how much progress we've already made just by having these kind of conversations. So, you might need to have a few more of those in the beginning of a project than normal, but we're not we're in improved times, not normal times, improved.
Yeah. Thank you. Ellen just asked me, can we end on that and the messiness, which I can agree with that. I think that's an excellent place to end. Thank you all very much. Thanks, everyone.
Okay, you guys just sit for 1 second. We just have a couple of announcements. That was incredible. This whole conference was incredible. Thank you so much to the speakers. We're so grateful. So everybody who attended, please expect an email tomorrow with a link to a survey. Your feedback's really important to us. And if you want to get a head start, there's a link in your program if you want to, fill out the survey right now, just saying. You'll all get a certificate of attendance, and in that email will be a link with a form to submit your AIA number if you want us to submit directly. And my last announcement is our 20th anniversary gala is on September 29th at the Lighthouse at Chelsea Piers. And our last speaker is Sabrina Canner, Executive Vice President at Brookfield. Thank you.
So, hello, as you heard, I'm Sabrina Canner, Brookfield Properties, and Chair of the Urban Green Board of Directors. On behalf of the board, I'd like to thank you all very much for attending today. Our movement is only as strong as our community. And based on what I heard and saw today, the thoughtful discourse and the creative solutions that were suggested and proposed, I'm feeling optimistic, maybe even a little confident in our future, and I hope you are feeling the same way. Urban Green is dedicated to decarbonizing buildings, and electrification, or whatever we end up calling it, is front and center in those efforts. We will continue our policy, research, and education work to achieve a future that we all want. A special thank you again to our lead sponsor, Carrier, to our reception sponsor, Highmark, and our host sponsor, NYU. Thank you, Cecil. Please, a round of applause. Thank you. I'd also like to thank the Urban Green team. They've been working very hard since January, putting this program together, and I think you would agree, quite successful. Would especially like to thank our programming team and our communications team, and a special shout out to Ellen, Viri, and Jack. Thank you very much for making this all work today. And this concludes today's program, but I'd like to invite you to join us across the hall for a networking reception and to continue the great discourse. Thank you very much.